So this one's Algebra 1, Semester 2. It's the third unit called Quadratics. It's the 9th lesson, graphing a, parentheses, x minus h, n parentheses squared plus k practice. This is a standard form of a quadratic. You can tell it's a quadratic because it's raised to the power 2, and we're going to explore these different variables in the equation. It's on creatormath.com or creatormath.weebly.com. And it's under the Algebra 1 tab. Follow this title of this lesson very carefully here, graphing this, okay, and you'll find it. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for these pages from creatormath.com. I don't know how quickly I can get there. I've got Desmos open. I'm going to show you that in a second. And I've got the creatormath.com open, at least I thought I did. So just go to the home page to orient you. It's creatormath.weebly.com right here, or creatormath.com. Type one or the other into Google and you should be able to find it. Make sure you know that the all of the composition book information is on the home page here. We're going to go straight to Algebra 1, which is where the lessons are. We're going to pass by the vocabulary down to the table of contents. This is on Semester 2. Here's exponents and polynomials, modeling two-variable data, and quadratics. And let's go to number 9 right here. These notes go on page 71, 72 of your comp book. Here's the title, graphing x plus x minus h squared plus k. Here's what the notes look like. You guys, I often have to open these notes twice for them to load. If I just sit here right now, did it load? Oh, I lied. It did open this time, but I've had to reload them several times, okay? So you're going to use these notes, put them in the right page of your comp book. This is going to explain a lot of the background to you of these problem set that I'm about to do right now, okay? With that said, let's go back to, can I go to Desmos? Where are you? They're going to want us to, using Desmos.com, graph the function f of x equals x squared. If we change the original function to f of x equals x squared plus 3, what happens to the graph? Here's what they're going for. Does the graph move up? Does it move to the right? Does it move to the left? Does it move down? So they're starting with a base equation here, x squared, and notice that what they're doing is adding a plus k. So this plus 3 represents a plus k in the original formula the generic formula of a quadratic that we're dealing with. And you want to understand, hey, if you give me a parabola x squared, so let's just put that in. Let's get rid of this. Let's take out this function, back up. Boop, 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 boop. Just x squared right there. And let's shrink this down. Oops, minus 30, minus 20. Where is our graph? Home. There we go. I clicked the home button, it did better. So this is a parabola. It's a generic, it's the base function, x squared. Anything we add to this now starts to move this around. They want us to add a plus 3 to this. So we simply go into Desmos and say plus 3. Look what it did. It moved our parabola up 3. All we have to do is say moves graph up 3. And just remember that plus 3 moves it up 3. So if you had a minus 3, it would move it down 3. If you had a plus 1, it would move it up 1. Just remember the way this moves, and now when we get to the next problem, we already understand a little bit about how this changes to this formula, make the parabola move around the graph. So now we start with x squared again. Now they want us to do a minus 2. We already know what it does. It moves it down 2, and if you don't believe it, go right back to this thing and just put in minus 2 here. Well, let's delete this out and say minus 2. There it is. See how it's down here now? Crossing at minus 2. So that's cool. Let's see what the next one is. So the next one gives us two things. Just to highlight this, it puts a minus in front of the x squared, and then it adds 6. So I know what the add 6 does. That moves it up 6. Got that. But what does this minus do? Well, let's get rid of this thing. Let's put a minus in here in front of the x squared. Wow, look at that. It flipped the parabola upside down. Now the parabola is opening downward. So now we're going to say right here, it's doing two things. It's flipping the parabola downward, and it's moving it up 6. Add the 6 in on this one. plus 6. Look at that. It moves it up 6 to where it's now crossing the y-axis at 6. So the parabola flips downward, ding, and moves up 6. Aww. Pretty cool, right? Because I'm starting to get the hang of this. Now I see what's happening. I'm now given a minus, so I know it flips it upside down, and I got a minus 7, so it moves it down 7. So I'm simply going to say the parabola flips downward and moves down 7. Go ahead and type it into Desmos, right? Just adjust the one we got. It's already upside down. All we need is a minus 7 right here. Back, minus 7. Ding. And we might need to say home again. Where's my home? Home. No, I like it better if I move it up. There we are. So we're at minus 5, minus 7, flipped upside down, moved down 7. All right, now we got several things going on here. We've got a minus 3, so we know it moves it down 3. But look at this. We have a number now in front of the x squared. So let's go back to Desmos, because we're just going to keep playing and do it the way they tell us. Let's put a 4 here. So we're going to put a 4 in front of the x squared. There we go. And let's even get rid of this, right? Let's get rid of the number afterwards. Let's say home. Notice what happens. Let's take the 4 out so you can see the difference. Or what I can do is a second one. How about that? Let's say ABC f of x equals, let's do just the x squared, x caret squared. So the blue one, did I just delete it? No, I didn't. Let's get rid of this. So the blue one is x squared. The red one is 4x squared. Putting a number, a coefficient, in front of the x squared narrows the parabola, makes it narrower. So the parabola moves down by 3 for minus 3 and narrows. That's what that means. Very cool. Now, instead of putting a number in front of this thing, we're putting a 1/3, a fraction. Okay? Let's keep our blue one in here, our x squared. That's the base one. And let's make this 4. Let's delete this out. And let's put a parentheses 1 divided by 3. And I want the parentheses here. There we go. I want the 1/3 times the x squared. So I'm using parentheses to separate out that 1/3. Notice that the red one is my new, the original, x squared is blue, so there's the original x squared. By putting a fraction in front of it, it made my parabola widen. All right, so we're going down by 4, and we're widening. The parabola moves 4 down and widens. So I don't know if you think this is cool. I do. Probably that's because I'm a math teacher, right? But it's very cool. You just adjust this. Now they're going to pair this up. We're widening it, moving it down by 3, and we're turning it upside down with the negative. So the parabola flips downward, moves down 3, or 3 down, and widens. Look at how much we know about a parabola now. Just by going one step at a time, we know it moves it down 3, widens it by the 1/4 being multiplied, and the negative flips it upside down. So the parabola flips downward, moves down 3, and widens. What else are they going to give us? I see what else they're going to give us. All right, minus 4 means it moves down 4. So I like, get all this on the screen at the same time. There we go. So the parabola moves down 4. That part we know. Check. This is new for us. And go back to the original formula. The original formula says x minus h right here. And that's what's happening. We have an x minus a number. So that number is h. X minus this number. Notice that the original formula had a minus in it. This one still does. So the h here is equal to 3. It is not equal to negative 3. No. Because the formula has the minus in it. So the h is 3 in this case. X minus 3, the 3 is positive. H is positive. It's got the minus in the original formula of this parabola. So let's go ahead and keep our blue. Let's take this right here and modify this. Maybe I can get rid of most of this. Okay, I got a parentheses. I've got an x minus 3, so I'm going to say x minus 3. I'm closing the parentheses, and now I'm going to say that whole thing is to the power 2. Look what happens. So blue, this is blue, is the original. Here it is right here with its vertex at 0, 0. When we typed in x minus 3 into this parentheses, we replaced this whole thing with a parentheses x minus 3. It moved over to the right, 1, 2, 3. How is it that an x minus 3 moves the parabola to the right 3? That seems backwards. Well, it goes back to the zero product rule, or when we're trying to find out where this root is, we need to put this thing equal to 0 over here, right? We need to make y equal to 0. The y-axis is 0 when we're crossing the x-axis. So when we do that, what the effect is, we get x minus 3 now has to equal 0 somehow. Well, what does x have to equal if x minus 3? We add 3 to both sides, and x equals positive 3. Gone, right? So the positive 3 on this side, I flipped it. Probably shouldn't have done that. Let's do it this way. X minus 3 equals 0, plus 3, x equals 3. So notice that if it's in a parentheses, for it to then equal 0, it has to flip the sign of this one by moving it to the other side of the equation. So x equals 3. Hence, we now see why this parabola moved 3 to the right. So a negative value inside the parentheses moves it to the right. A positive value inside the parentheses is going to move it to the left. So let's finish up. The parabola moves down by 4, right there, and moves to the right 3. All right. Can we predict what happens next? If it's x plus 3 in the parentheses, can we go ahead and say it's going to move it to the left 3? You okay with that? That's what happens, and go ahead and just plug it into your Desmos to see what happens, right? In fact, let's do this one right here. Back, plus. There we go. See how it moved to the left 3? Oh, the parabola moves to the left 3. I'm hoping that they give us a negative now. Yay! Oh, okay, I'm so excited. This seems like a full range. So the parabola is going to move to the right 3. Why? Because it's x plus 3. We have to put it equal to 0. By the time you move it to the other side of the equals, it's going to be a negative 3. That's the right 3. Well, okay, I'm lying. I'm solving x. Let's do it this way. Equals 3, minus 3, minus 3. There, x equals minus 3. It moves it to the left 3. There, I misspoke, and I'm so sorry. All right, so I see the positive 3. I know it moves to the left. I was so excited to get to this, the minus, which flips the thing upside down. So I know already, even if I draw this myself, I'm going to go to minus 3, and it's going to open downward. So this thing's going to go like this, right? And don't take my word for it. You've got a tool at your disposal to plug in x plus 3, we know it moves it here, and we just put a negative in front of this, or minus, and it flips it upside down. There you go. A little bit like my drawing. I made mine a little bit too wide, but pretty much it. So the parabola flips downward and moves to the left 3. This is on creatormath.weebly.com. You are going to the Algebra tab, and you're finding this title. Match up the titles exactly to find the video solution to this problem set. And use your graphing calculator on desmos.com right here to do all the graphing and to experiment with this and to learn about quadratics.